Hi everyone. As we move through the analyze phase, we're going to start analyzing data and telling if it's statistically different from other data or not. And so to start that, we're going to take a look at normality, which uses the standard bell curve. What the standard bell curve is for is sort of a master curve for data. You can basically scale all normally distributed data to fit this curve. And it's called the normal curve, or sometimes the z-curve. And you can use it to not only determine if your data are statistically different from each other, but to calculate probabilities. And so you may be thinking, well, wait a minute, we already went over probability in the last phase, and there are certain rules for it, and that's how you calculate probability, right? Well, that's how you calculate probability of an event. But if you want to calculate the probability of something falling below a certain weight or falling above a certain temperature or between two values, you actually do need to use the standard normal curve. So let's take a look at how that happens. The first thing you want to think about is when you're looking at a problem that is asking you to do some kind of probability calculation, you need to sort out whether this is asking you to use the rules of probability for an event occurring or the probability of something being greater than, less than, or between something. So if you see any of these on the screen right now, that should tip you off that, oh, I need to use the standard normal curve, not my probability rules. So greater than some percent, less than some percent, and between some percent. Or greater than some value, less than some value, and between some value. That'll tip you off that you need to use the bell curve. And here it is. So we have a sample bell curve, and let's say these are just weights of a food product. So mean weight is the same as medium weight, and that's 20 grams. And these little marks here show you standard deviation. So here out at the first standard deviation, we are at 17 grams. Here we are at 23 grams. So notice that these are symmetrical around the mean because we are at the first standard deviation. All right. So let's say we want to know the probability of something being less than 17 grams. To do that, we're going to look up on the table what that is, and we have some lecture videos about that showing you how to do that. But it really helps to keep you straight what you need to look up on the table if you draw the picture of the bell curve and then do some shading. So we're interested in the probability that the weight is less than 17 grams. And so that is this area right here in blue. All right, so the probability that everything under this blue area of the curve right here, that area under the curve is going to give you your answer. If we want the probability that the weight is greater than 17 grams, well, we need to shift where the blue is because now it's over here. And so all the blue area under the curve here is what we're interested in. We don't care about this anymore because we want to know greater than 17 grams. So we're interested in this area. Now, if we want to know the area that is between 17 and 23 grams, that's this particular area right here. And so this is the area that we care about. So when you go to calculate, you're going to have to think about, okay, what is my table data telling me? And often there's a little picture on top of the table with one end of the curve shaded. So you might see shading like this, or it has this little end shaded right here. And that means what your table is telling you that the probability of everything of that value and less, that is the number in the table, that probability. If your table has shading over on this side, on the right side, then it's telling you the probability of that value and greater. So just make sure you know what table you're looking at when you're looking at these values. Otherwise, you're going to be off by 1 minus the probability you just looked up, based on the rules for calculating these things. Okay, so let's use our shading to figure out what we're going to look up. Let's say we have what's called a left-tailed table. And that's if you look on the little chart above the table and it looks like this. You got shading on the left side. That's left-tailed table. So if we want to calculate the probability of something being less than 17 grams, we calculate our z-value from this data and our formula, which is shown on Blackboard. And we look at that value in the table, and we get our z-score. And so that'll be a value between 0 and 1, and that is our probability of this particular event happening, that our weight is less than 17 grams. So that's good. If we want greater than 17 grams, so this area, what we're going to do is we're going to calculate our z-value again, and we're going to look up that value in the table, but we're not going to use that z-score. Because remember, we've got a left-tailed table, and it's giving us this white area right here. We don't want that area. We want the blue area. Well, the area under the bell curve sums to 1. So we just take this white area and say 1 minus that area, and that will give us our blue area. All right, so we know how to calculate less than, we know how to calculate greater than, but what happens if we want to calculate between two values? So we want this area under the curve. Well, here's where we actually have to do two different calculations. The first one, using our left-tailed table, is everything that is less than 23 grams. So you have to calculate your z-value for that and look up your z-score. Second thing you have to do is calculate everything less than 17 grams and look up that value, which is the darker blue right here. So you can see that we have a lighter blue shaded region and a darker blue shaded region from our 23 and our 17 respectively. What we're going to do to find this area under the curve, the light blue area, is take our z-score from 23 and subtract out our z-score from 17. So this darker area is basically a double counted area, and by subtracting out the z-score at 17, we're going to get this area right here between 17 and 23. So that's how you calculate a value between 2 points here. So keep these things in mind as you're going through the normality problems this week. We'll also have hypothesis testing this week, and we'll look at how we use this particular standard normal curve to tell if two populations are different. These are great tools for analyzing your data, so as you're working on course projects and other projects, think about using hypothesis testing and the standard normal curve to see if your values are truly different or if they can be considered the same population and you don't have a significant difference.